point. In this video we will solve this partial differential equation, which is partial square phi over partial x square plus partial square phi over partial y square is equal to 0, and boundary condition are phi of 0 and y is equal to 0, and phi of a and y is equal to 0, and phi of x and 0 is equal to 0. Partial derivative of phi with respect to y at y is equal to b is equal to f of x. We will solve this equation by separation of variable. Let phi, which is function of x and y, is equal to u of x, v of y. So above equation become partial square u v over partial x square plus partial square u v over partial y square is equal to 0. This can be written as v d square u over d x square plus u d square v over d y square is equal to 0. This is equation number 2. Divide equation 2 by uv. So this become 1 over u d square u over d x square plus 1 over v d square v over dy square is equal to 0. This can also be written as 1 over u d square u over d x square is equal to minus 1 over v d square v over dy square. This is equation number 3. Equation 3, left hand side and right hand side are equal to some constants, which is minus lambda. So this become 1 over u d square u over dx square is equal to minus 1 over v d square v over dy square is equal to minus lambda. This is equation number 4. This can also be written as 1 over u d square u over dx square is equal to minus lambda. This is equation number 5. And minus 1 over v d square v over dy square is equal to minus lambda. This is equation number 6. Equation 5 can also be written as d square u over dx square plus lambda u is equal to 0. This is equation number 7. And equation 6 can be written as d square v over dy square minus lambda v is equal to 0. This is equation number 8. Now we will find the condition for equation 7 and equation 8. Phi, which is function of x and y, is equal to u of x, v of y. Now we have phi of 0 and y is equal to 0, means put x is equal to 0. So this become u of 0, v of y is equal to 0, implies u of 0 is equal to 0 and v of y is not equal to 0. Similarly, phi of a y is equal to 0 implies u of a is equal to 0. Now phi of x and 0 is equal to 0 implies u of x v of 0 is equal to 0, means v of 0 is equal to 0 and u of x is not equal to 0. Now we'll discuss following case. When lambda is equal to 0, equation 7 becomes d square u over dx square is equal to 0. And the solution of this equation is u of x is equal to c1 plus c2x. Now we'll use boundary condition to find the value of c1 and c2. U of 0 is equal to 0 implies c1 is equal to 0. So u of x is equal to c2x, and boundary condition u of a is equal to 0 implies c2a is equal to 0. Since a is not equal to 0, so c2 is equal to 0. So u of x is equal to 0. And phi, which is function of x and y, is equal to u of x v of y. Since u of x is equal to 0, so phi of x and y is also equal to 0. If lambda is equal to minus k square, then equation 7 becomes d square u over dx square minus k square u is equal to 0, and the solution of this equation is u of x is equal to c3 exponent kx plus c4 exponent minus kx. Now we'll use boundary condition to find the value of c3 and c4. u of 0 is equal to 0 implies c3 plus c4 is equal to 0, and c3 is equal to minus c4, and u of a is equal to 0 implies c3 exponent ka plus c4 exponent minus ka, and c3 is equal to minus c4, so this becomes c4 multiplied by exponent minus ka minus exponent ka is equal to 0. Since exponent minus ka minus exponent ka is not equal to 0, so c4 is equal to 0. Since c4 is equal to c3, if c4 is equal to 0, then c3 is also equal to 0. So u of x is equal to 0, and phi, which is function of x and y, is equal to u of x v of y. Since u of x is equal to 0, so phi of x and y is also equal to 0. If lambda is equal to k square, then equation 7 becomes d square u over dx square plus k square u is equal to 0, and the solution of this equation is u of x is equal to d1 cos kx plus d2 sin kx. Now we'll use boundary condition to find the value of d1 and d2. u of 0 is equal to 0 implies d1 is equal to 0. So u of x is equal to d2 sin kx. Now we'll use second condition, which is u of a is equal to 0 implies d2 sin ka is equal to 0. Since d2 is not equal to 0, so sin ka is equal to 0, and ka is equal to sin inverse 0 is equal to n pi, and k is equal to n pi over a. So u of x is equal to d2 sin n pi x over a. If lambda is equal to k square, then equation 8 becomes d square v over dy square minus k square v is equal to 0, and the solution of this equation is v of y is equal to d3 exponent ky plus d4 exponent minus ky, and this can also be written as d3 cos hyperbolic ky plus d4 sin hyperbolic ky. Now we'll use condition to find the value of d3 and d4. v of 0 is equal to 0 implies d3 is equal to 0. So v of y is equal to d4 sin hyperbolic ky, and phi of x and y is equal to u of x v of y, and u of x is equal to d2 sin n pi x over a, and v of y is equal to d4 sin hyperbolic n pi y over a. So let d2 d4 is equal to a n. So by superposition principle, phi of x and y is equal to summation n is equal to 1 to infinity a n sin n pi x over a sine hyperbolic n pi y over a. Now we'll use condition to find the value of an. Now we'll use partial phi over partial y at y is equal to b is equal to f of x. So this becomes f of x is equal to summation n is equal to 1 to infinity an n pi over a multiplied by sine n pi x over a cos hyperbolic n pi b over a. Now multiply by sine m pi x over a and integrate from 0 to a with respect to x. So this becomes integral from 0 to a f of x sine m pi x over a dx is equal to an n pi over a sin cos hyperbolic n pi b over a integral from 0 to a sine n pi x over a sine m pi x over a dx. When n is not equal to m, this integral is equal to 0. But when n is equal to m, this integral becomes integral from 0 to a f of x sine n pi x over a dx is equal to an multiplied by n pi over a cos hyperbolic n pi b over a integral from 0 to a sine square n pi x over a dx, and this integral gives us a by 2. So and a n is equal to 2 by n pi multiplied by 1 over cos hyperbolic n pi b over a integral from 0 to a f of x sine n pi x over a dx.